An amplifier composed of two common source stages is given. The key component values are annotated. The arrow of the source terminal of transistor M1 is not shown on purpose. You need to figure out where it is. This is very easy, and in the previous videos I explained why. So the source is here. It's common source stage we take from the drain, hence this is the source. Find the approximate frequency of the pole formed at the output of the amplifier. Which of the given choices is closest to your estimation? So we have to choose one of these. So we are now interested in the output pole. So we can associate a pole frequency with this node, the output node. And it will be certain equivalent resistance times certain equivalent capacitance. So let's first attack the equivalent resistance. The equivalent resistance here is dominated by is given actually by R out 2. Yeah, so if we estimate the equivalent resistance in this node, we disconnect this. This is floating, and the only device that is connected is M2. So the output resistance of M2 will determine the resistance, equivalent resistance of this whole node. So R out 2. And how we can get it? We have the early voltage and we have the biasing current, which is I drain. So VA is 10 volts divided by 0.2 milliamperes, and now we get 50 kilo ohm. Great, so we have the equivalent now the equivalent capacitance. So what is the equivalent capacitance? Let's look at all the capacitances that are connected. So we have this one, which is the gate drain, and we have this one, which is the drain bulk actually. So they are in parallel. And why in parallel? Because the bulk here is connected to VDD, and when we estimate the equivalent capacitance, this is like connected to ground. So we just directly add the drain bulk capacitance. And now we have the gate drain capacitance. Now this node is like a reverse Miller. So we'll have to take into account that it is 1 plus 1 over A, where A is the gain of this stage. Now usually this is a big number, so it would be something like, I don't know, high number. In any case, this will be dominant. So I can approximate that this is simply 1. So this is simply, I can approximate that C equivalent is C drain bulk plus C gate drain. If I get a result and it's close to 2 values, not 1 value, then I can revisit my approximation here. All right, so let's see what this is. Drain bulk is 5 femtofarad, and gate drain is 5 femtofarad. So in total 10 femtofarad. Now I can calculate what is the time constant. I have 50 kilo ohm, and here I have 10 femtofarad. So then the output time constant, the output pole is 1 over the time constant, and it will be 1 divided by 50 times 10 times 10 to the power, so this is 10 to the power 3, and this is minus 15, 10 to the power of minus 12. All right, so this will be, so this is 500, and this is 10 to the power of 9, and I have here 1000 divided by 500, and this is 2. So this is my answer, 2 to the power of 2 times 10 to the power of 9 radians per second. Let's see if I have such answer. All right, I have. Great. I have this answer. Let's see if I have any other answers that are close to this. Yeah, not really, not really. So this approximation is all right. This approximation is good. So I'm very close. All right, so thank you very much.